Alright, so here's an example with a linear piece of DNA. So the difference with linear DNA is you're going to be using lines. So I'm just going to draw, I guess, an equation that might help you with linear DNA. So the number of fragments you have minus 1 equals the number of cuts you have. This is different from a plasmid just because the number of fragments you had equals the exact amount of cuts you have. And that makes sense because if you consider this line right here and you cut it only once, so this is one cut, you're going to land with 2 pieces or 2 fragments. So in a problem, you'd have 2 numbers even though there's 1 cut for a linear piece of DNA. And if you had 1 cut with a plasmid, it would just end up being 1 line. So that's the difference. So back to the problem. Let's determine how many cuts each single digest does. So B has 3 fragments, so it makes 2 cuts. Because it's the number of fragments equals minus 1 equals the number of cuts. So ECO makes 1 cut since there's 2 fragments. And since N has 2 fragments, subtract 1, you get 1 cut for N as well. So let's make our single digest. For B, we have 170, 420, and 3720. So single digest is going to be a line, and B is going to make 2 cuts. So I'll make a cut right here. This smaller area is going to be worth 170. And we'll make another cut right here. This smaller area is going to be worth 420, and this larger area will be 3720 since there's 2 cuts. So we got 2 lines, 2 cuts, we're good. Now let's do E. We got 11 and 3200. Let's draw a line. Since there's 2 fragments, there's only 1 cut, so we're only going to have to cut it once. So here, we'll cut it right here with E. This smaller area is going to be 1110, and this larger one's going to be 3200. Now let's do N. So we got 1500 and 2810. Let's draw a line. So there's 2 fragments, that's 1 cut. So we'll make 1 cut with N. This smaller area could be 1500, and this larger area is going to go to the bigger number, which is 2810. So let's now do our double digests. Oops, wrong color. Okay, so we're going to do B plus E. There's 170, 420, 0, and 2610. So we're going to do the same thing as last time. We're going to use the single digest with the most amount of cuts. So compared to E, if we're comparing B and E, B has 2 cuts and E has 1 cut. So we're going to use B since it has 2 cuts for our double digest. So it had a cut right here and a cut right here, and the fragments were worth 170, 420, and 3720. So as we could see, the 117 can stay the same, so we don't have to cut it up into any pieces. The 420 also stayed the same, so we could cross that out. However, this larger piece is going to be split up into these 2 numbers. If you add these 2 numbers up, it equals a larger piece. So let's cut that up with E, because E makes 1 cut. So we'll cut it with E right here. This larger area is going to be 2610, and this smaller area is going to be 110. Cool. So let's do our double digest with E and N. We got 390, 1110, and 2810. So B and N both make only one cut. So we could use either single digest. And I'm just going to use the one with E just because the 1110, we could just, it'll stay conserved if we use this one. But also, as you can see, there's a 2810 for this one. So you could really use either one. I'm just going to use E for my example. So E made a cut right here, and this region was worth 1110, and this area was worth 3200. So as we can see, this area is worth the same, so I'm just going to cross out this because it doesn't get split up into anything. However, this 3200 piece is going to be split into these two numbers. And since we use the single digest for E, we're missing N, so that next cut is going to be made by N. So let's make a little cut by N. This smaller area is going to be worth 390, and this piece is now going to be worth 810. So our double digest for those is done. And I'm going to just do the double digest over here for B and N. 170, 420. Right, so let's just draw our line. So comparing the single digest for B versus N, B had more cuts, so we're going to use B in our double digest. So B made a cut right here. That fragment was worth 170. This one right was worth 420, and this larger piece was worth 3720. So as we could see right here, 170 stays the same because that was a fragment size found. Same with 420. So we can see that 3720 gets split into these two numbers by N. Since we use the single digest for B, we're missing the enzyme N. So that piece is going to be cut by N into 2200, and the smaller area is going to be split into 1500. Cool. So let's make our full digest. So we could use either the double digest with B and E or the double digest with B and N, because both of them have the same amount of cuts. I'm going to use the one right here since it's just closer to me. So there was a cut made by B right here. This fragment was worth 170. B made another cut right here, and that new fragment was 420. And N made a cut right here, and it was 1500. And this larger area was 2220. Okay, I wrote that wrong. Okay, it was that. And we're just missing E. So again, we're going to do the same thing as our plasmid one. We're going to figure out what numbers in the double digest involving E equals any of the numbers down here or down here. So let's just add up a bunch of numbers and see if we get anything. Let's do 1110 plus 420. Nope. Okay, cool. So out of all of these numbers, these two numbers, 390 and 1110, they equal 1500 right here. So this 1500 can be split into these two numbers. Let's go do that. So right here, 1500, it can be cut by E. The smaller area can be 390. And this larger area right here is going to be worth 1110. So as we can see, this makes sense because if you go back here, B made 2 cuts, E made 1 cut, and N made 1 cut. So 2 plus 1 plus 1 equals 4, so we made 4 cuts. So we have 4 enzymes, 4 cuts. And since it's a linear piece of DNA, we have 5 fragments, so that makes sense. And that should be your answer. At least the enzyme should be in the correct order.